Okay, the second technique we should know to analyze the dynamics of a difference equation system is variable stacking. This is the technique to convert a higher order system into a first order system. Let's see the case of the second order system because the third order, fourth order, they should be the same. The second order system should look like this. The date t plus 2 value of k is equal to some constant a times date t plus 1 value of k plus another constant b times date t value of k. This is a second order system because the state depends on the two previous dates. To convert this system into the first order system, add a very trivial equation, kt plus 1 equal kt plus 1, of course, and then express these two equations together in the matrix form. Then this system should look like this. The vector of kt plus 2 and kt plus 1 equal a 2 by 2 matrix AB10 times another vector composed of kt plus 1 and kt. By denoting this vector of two k's by capital K, we have this expression capital KT plus 1 equal matrix S times capital KT. This matrix S is this 2 by 2 matrix. Okay? So we have a first order system because capital KT plus 1 depends only on the previous date, capital KT. The exactly same thing can be done even when this variable k is an n-dimensional vector. In that case, the coefficient a and b are both n by n matrices. We again add a trivial equation about kt plus 1 and put them together. We have very similar expression, but now this matrix S is this 2n by 2n matrix, and capital K is 2n-dimensional vector. Now you should be guessing what the process should be like if the system is a third-order system, so that kt plus 3 is a function of the three previous dates, kt plus 2, kt plus 1, and kt. In that case, you add two trivial equations, one for kt plus 2 and the other for kt plus 1, and express them together, put them together. We have a large vector composed of kt plus 3, kt plus 2, and kt plus 1, and this vector is determined by the previous vector, which is composed of kt plus 2, kt plus 1, and kt. The dimension of the state vector and the dimension of the system tripled, but it is no longer a third-order system, it is now merely a first-order system. I think a similar idea can be used in a daily life. Suppose that you have to make a budget plan every month. Suppose that in order to make a new budget plan, you have to refer to two previous budget plans, one from the last month and the other from the month before last. Okay, every month you have to make a budget plan, and for that purpose, you need information about the budget plan of the last month and the budget plan of the month before last. So every time you have to open and print out two documents, one budget plan you made last month and the other plan you made 2 months ago. It's troublesome, and at some point you notice, wait a minute, every time I make a new document, why don't I include not only the new budget plan but also the budget plan of the last month? If I do that every month, then I no longer have to go back to two previous documents. One previous document is good enough because the last document includes the budget plan information of the last month and the budget plan information of the month before last. Let me repeat. When you make a new budget plan, you need information about two previous periods, last month and the month before last. So when you make a new document, if you include in your document only the plan for that month, then you have to go back to two previous documents to make a new plan. But if you include in your document not only the plan for that month, but also one old plan from the last month. If you do that every period, you don't have to refer to two previous documents because the last document includes enough information, the budget plan of the last month and the budget plan of the month before last. Okay? So the length of the document might double, but you have only to refer to one previous document. And I think that's essentially the idea of stacking variables to convert a higher order dynamical system or even a high order AR1 process into a first order system or process.